If there's a chair, sit in it. Otherwise, it'll be quick, I promise. And I'm gonna stand with you. So, all right, let me get the music out of the way. Let's get this program started, right? You like leaning? All right, so I think we've got audio, we've got projector going, a bunch of screen shares happening, instructors are ready, mentors are ready, and we've got a nice little crowd here. So all y'all just smile while I take this photo, because it takes a lot to show up on a Saturday. So pats on your backs, and just thank you so much for joining our second hackathon. We're calling it the Designathon this semester. And by the way, if you find more chairs, you want to just do what he's doing, go for it. I'm totally all on board for self-organization, right? If something's not right, fix it. That's how I see it, right? So if you're not comfortable, go get a chair. Make your own chair. In fact, we've got a fab lab where you could design your chair, and then if it's really nice, you can sell it. I like Israel there, right? He's got the comfy one. He's got the comfy sofa. All right, so let me see if I can zoom out of this. I don't know why it was zoomed into me. All right, there we go. We zoom back. So let me quickly tell you about what our goal is today, right? So you're participating in a Designathon which has 3 mini hackathons. I want to say 2 Saturdays ago, we've had our first hackathon where we went and created some art. And we gave some challenges, students created some art, and then we gave away $500 to the top 3 teams. This hackathon, we're going to digitize printed art. So if you drew something, or if you haven't drawn anything before, you can draw something today. And then you have instructors and mentors here who's going to teach you how to take a printed file, or hand-drawn file, and then learn this software to be able to put it into a computer as a 2D or a 3D model. So they're going to teach you how to use this software. So we're going to learn Fusion 360, at least get a 101 on it. What was the other one, Reggie? Help me out.
Inventor?
Inventor, which is Autocad.
Yes.
And then also you may get exposure to, I want to say it was, so the way I see this is Google Sketch, Maya, all of these other softwares are kind of this, they're working off the same methodology as Inventor and Fusion 360. So once you learn one, you kind of sort of know the others, right? It just takes a confidence for you to use it and move forward. So our goal is, I'm going to just skip through. I just realized this is from our day 1. So you're going to see me skip like 70 slides because this was all from the first one. And let's keep going. This was our innovation thinking. I'm just going to keep going. And this was the giveaway. Keep going. All right. So that was our day 1. In fact, I'm going to see if I can go back. There it goes. All right, keep going. Almost there, guys. Design thinking, website. Oh, we had pizza. We're going to have pizza today, so at least that's something to look forward to. Food at 12. And we're going to make submissions. So let's keep going. Sorry, this slide. Okay, there it is. This is our second hackathon. So, go back one. Back one. There's no control to this guy. It's giving away all my secrets. All right, here we go. Stop right there. Do not stop. There we go. All right, plan for the day. So I know it's a little hard to see. So what I've done is I've put this entire thing on YouTube. So if you've got a smartphone and you want to go back and see any of these slides, in fact, anything that our instructor is teaching, you want to go back and look at, you can. And I'm going to share with you the link on YouTube that you can go to. So everything I'm talking about right now is being live streamed. It's put on YouTube as an unlisted link, and I'm going to give you the short link that allows you to see it, and you can go back and catch up if you missed anything. But this slide, and I'm just going to stop here. There's the YouTube link. It's bit.ly/design8cc. So if I were you, I'd take a screenshot of that, or just take a copy or type it in your phone. So bit.ly/design8cc. If you need help, we're going to set that up for you. Any of the mentors can help you and get you there. So now let me go back and let's talk about the day. So this is going back or forward. There it goes. Some of you are taking pictures, so I'm going to give you all a second. But bit.ly/design8cc. And I realized the reason I'm doing this is I'm watching the YouTube stream and there's a 3-second lag. So I think that it's on the, that's what's happening. See, I figured it out myself. So I'll watch here. This is real. There we go. So let's go back to what's going to happen today. So today we're going to do a quick recap and orientation, which is what's happening right now. In fact, we had a call yesterday on Zoom at 6 p.m. where we went and celebrated all the ideas that had come in. I'll show you all a little bit of the projects that were submitted and some of the art. Some of you in the audience made those projects. You've already won some cash prize. And now you're trying to get your design onto a 3D model today. So we're going to be here from 9 to 3 p.m. Okay? I shared yesterday that we have 2 Fab Labs. One is the West Houston Institute, and the other one is right behind you called the Advanced Manufacturing. These Fab Labs, they're short for fabrication labs. They have everything you need to be able to create a physical product. So in order for you to make a 3D print or cut something on a laser machine, you have to have a digital file that you can hand over to these guys. And in fact, they can help you if you need tweaking with your designs. But before you go to them, you have to have a digital file. So that's what we're going to do today, is learn how to create that digital file. We're going to have lunch in the middle, and then everything's going to be due by Thursday, 8 p.m. So earlier we said we're going to make everything due today, and at 5 p.m. you had to have judges, but then the faculty at the Digit-a-thon office said, no, Ravi, you got to give them more time. So we gave you 4 days to work on your digital files. But we're not going to leave you alone, right? You'll have access to the Fab Labs. They're going to be open. So the West Houston Institute, I'm told they're open Monday to Thursday for this project from 10 to 3. Regular office hours. You can walk in, say I'm working on a Designathon project and I need help and I want to do XYZ for my project. They'll help you. The Fab Lab here will be open Tuesday to Thursday from 10 a.m. to 7 p.m. So it's just a matter of you coming back and, or working with the Fab Labs for this project. You could also work on this at your home, at your own convenience. You could work on this in your schools at the computer labs at HCC. So it doesn't matter how you get these digital files created, as long as you submit it on our DevPost website by Thursday, 8 p.m. We'll have judging take place on Friday for the projects that come in, and then we'll give out the second $500 for the hackathon. Okay? So does that kind of make sense, what we're doing today? Any questions? Any thoughts about the process? So I'm seeing some no's like, no, I'm okay. Yeah? Does it make sense that you're going to take a hand-drawn file and then try to convert it into a digital file? And does it make sense that once you have a digital file, you can go to these Fab Labs and print something physical, whether it be made with acrylic, 3D plastics, as they have, wood. You could design your trophies or your projects in those Fab Labs. All the materials and supplies is covered. So it's a matter of just getting a digital file put together and learning the skill to be able to do so. Now I told you this was the second hackathon. So we have a third one, which will take place on May 21st. I think a lot of you are signed up for that one as well. That one will take place in the West Loop Auditorium. We will have the public other people, other students invited. Come see what you've created as part of an expo. So already, since it's Earth Day, we have about 9 projects that were used for creating Earth posters. Those students were going to come. Already we have, 43 designs that were created from the first hackathon. We're going to showcase those. All designs will be showcased there. The winning students will also get to showcase their projects. Whatever you create here today, those digital files will also be showcased. And we'll have students who have businesses that have started. They're going to be showcased there. So it's going to be a full festival of just celebrating whatever students have created. It's going to be in the auditorium. We're going to have music and food. We're going to enjoy ourselves. After the expo, from 10 to 12, the expo, we're going to have some panels. People from the community will come by and talk to you about startup resources. If you're interested in converting all the skills that you've gained and turning into a small contractor or or an employer or a small business or a freelancer, we'll teach you how you can do that. How you can start your own business as a graphic design company or as a digital creative, right? Or as an artist. There's a creative entrepreneurship. It's a real thing. We're going to teach you that. If nothing else, we'll make you a tech entrepreneur because you're going to get skills from some of the best at HCC. Okay? So you learn from the panels. You get a chance to showcase your skills and talent at the expo. The last thing we're going to do is we're going to have a competition. If you guys know what Shark Tank is, have you seen what Shark Tank? Yeah? Where you're pitching your idea, your business idea or your persuasive pitch to a group of random strangers, judges in this case, for some seed funding, some money. So we're going to have about $2,500 up for grabs on that day. And that becomes, so the Designathon will have a $1,000 pot, but we'll have an additional $2,500 pot for people to say, I want to start a business, this is my branding, this is who I am, this is how I'm going to get a customer, and this is why I want to start my business today. And that is $2,500 just for your ideas of starting a business, okay? Or small business. So that's kind of our full game plan for the semester. You're, again, right in the middle at the second, so welcome. And now, I want to kind of jump over to some of the mentors and speakers that you'll hear from today. So myself, I'm Ravi Brahmat. I'm the Director for Student Innovation and Entrepreneurship at Houston Community College. I have the awesome privilege of hosting such events, competitions, workshops, hackathons, as well. Reggie Leathers, who's going to be talking to you about Fusion 360. So Mr. Leathers, faculty for the Digit-a-thon department. We have Israel Garza here as well, back there. He's got the Idea Studio shirt there. Israel Garza is the manager at the West Houston Institute, which is a fantastic building just like this one on Hayes and Westheimer. It actually falls on the metro route as well. I know this campus doesn't, right? So there is more public transportation available to that building as well. And they have a huge 10,000 square feet makerspace. So what you see back there, just multiply that by 4 times the space. And again, they have awesome students who can help you, or student workers who can help you work on your projects. They can make cool 3D things. I've seen a guy that's made the Iron Man mask. You guys know the Iron Man, right? They've made a mask for it. You can put it on and it lights up and everything. Those are all student creative projects. I've also seen them make like a drone that can fly a mile into the sky. So they've got some smart students there that you can leverage. Malcolm King, is there Mr. King here? Once he's here, he'll be able to help you with your project. We've also got Ming Fan. I think Ming's right there on the side, right next to Israel. He's the interim chair for drafting and design at the college. So thank you so much for being out here. Ming's going to talk to you about Inventor on Autocad. And he'll be able to show you a little bit of a demo there. And then we also have some other faculty, Andre, Harold, and Marcio. Andre's not going to be here. Andre's running West Coast. He's a marathon runner. This weekend he's out there running. So we wish you well. We wish you have a good run. and come back to us safe and healthy. He's more healthy than all of us to be running a marathon like that. But then we'll also have some other faculty join us today. They're going to be around. You also have Roland Fields in the Fab Lab. He's going to be around not just today, but also for the remainder of this week to really help you with your projects. Okay? So these are the folks you want to get to and say, how do I do X, Y, and Z? All right. So for Mr. Leather's presentation, so this is where we had to be really creative. This morning, Mr. Leathers and I show up, and we had a problem, right? The problem was we don't have enough outlets in the main lobby. So our clever computer folks said, we'll put it all across the edges, and then we're going to present here. So in the hall, we have all of the MacBooks for you to use for Mr. Leather's presentation. But I understand you cannot see the screen from the halls. So guess what you're going to do? You're going to join us on YouTube, right? That YouTube link. So when you get to your laptops, go to YouTube. Type in bit.ly/design8cc, all lowercase letters. And then you'll join us live on your screen watching Mr. Leathers. So even though we're in person, we're going to pretend it's a virtual session. Okay? That sounds like a plan? I'm hearing some chuckles back there. But we have to make do with what we're given, right? So I'm sure you've heard the saying, when life gives you lemons, you make lemonade, right? So this is our lemonade for the day. And I hope that we can make this work. So Mr. Leathers, you tell me when you want me to dismiss them to their chairs, or you want to take a second to share your screen. Welcome.
Yes, we can share my screen and we can start on you.
Awesome. Do you want to come up here, or do you want me to just turn the camera on you? And how do you want us to do this?
You can turn the camera on me. That's fine.
All right.
Okay.
So the camera gets turned,
And we're going to talk about what we're going to do.
and you're going to talk about what you're going to do. So here we go.
Okay.
Give me a second. I'm going to stop this screen share so we could all see you. So by the way, welcome back from the pandemic. We're still trying to figure this out. Wait, it's here somewhere. Let's stop the screen share. If you could share your screen, that would be great. And that way.
You'll have to set it up because mine is all one and then you have to come back and this.
Got it. All right, so we'll go here.
We're good. Oh, perfect.
All right, so
When you're ready.
all right, we're ready. You want us to?
Okay, well, I can.
You let them know when they should go.
Okay, well, I'm ready to start talking about what we have here.
But do you want them to be on the computers?
Yes, if
Okay, okay.
they, so they can see what I'm doing there.
Okay.
And what we'll do is once I go over everything, if you want to go, we can walk around.
Okay.
Because if
All right.
okay.
So at this point, let's get you your laptops. Okay. So if you all just get up and go to the halls, you're gonna go to that link, the bit.ly/HCC design. If you want to use your laptop, you can hit sit here. Yeah, if you have your own laptop, you're welcome to stay here. But if you don't have a laptop, we've got laptops for you. Just find a laptop, sit down, and go to that YouTube link. Yeah, take some chairs with you. So far, we're doing the YouTube. You can use the thing around. And the software is Fusion 360. It's free. You can download it.
And what they can do, Robbie, is when I'm working on this, they can see exactly what I'm doing. They don't have, things behind me.
Okay, perfect. So right now, your screen is being shown.
Okay, great. Just let me know when you start, and I'll start.
Okay, cool. So if you guys want to take your screen and flip it around, There were no chairs. If y'all want to sit down, go for it. Yeah, y'all can sit there and enjoy this. Go straight to your computer. Fillet / Designathon.
Hello? Robbie? Testing, 1, 2, 3.
And he asked me about Autocad. So what we can do is after the I won't be here after. Okay. Well, what do you want to after the I can show you. I have a couple like videos I can show. Let's do that. Let's do that. Autodesk Fusion is that's Inventor, right? They have software. What's that? Because it's not Autocad. Okay. Yeah, you do Autocad. When you get a new laptop, you just swap it out. A new laptop, a separate laptop. A separate laptop.
All right, Robin. You want to test it now? Is it good? Testing 1, 2, 3. Just testing 1, 2, 3.
You have the mouse? You good? Yeah, you have this on. I think we can hear you say 1, 2, 3.
1, 2, 3. Can you hear me, Robbie? Is that a good test?
Yeah.
Okay, good.
Testing.
Testing 1, 2, 3.
You want to put here or where?
For now, give it to Israel. Just have it set up.
After that, you set it to him.
Yeah, he'll bring it here.
Okay, I just download it and.
Yeah, just load it and have it for him.
Okay.
Okay, so you're good to go. Just
We'll mute that now, right?
yeah.
Okay, good.
You guys go to that YouTube link, but you don't have to.
So, Robbie, to get your screen.
All right. There's a 10-second delay for everything you're doing.
Let me ask you something. Can we make this is gonna not stay there?
Yeah, I'll go away as soon as we put it.
We unmute. Go ahead.
No. Okay, so when I roll over these menus, this is in the way.
See.
Just grab this guy and throw it to the side. I'll go away.
So what I'll do is I'll keep it right in the middle here, and so we'll mute me, right?
Yeah, just stay unmuted because that's the only way they can hear.
Oh, that's something that you can? Okay.
Yeah.
So we're using your mic. What I'll do is I'll kind of maneuver over this so it can all be. Okay, that's good.
So walk them through how you even download this file because it's on the computer already.
No, what we're going to do, once you open the software, we want this particular one here that we see to stay here, or else I can just have to create what I'm looking for. Okay, so we'll start from there, and then we'll actually work out what we're looking at. So what I'll do is let's go ahead and delete this thing, because if they don't, we want to start with something at least in the screen so we can see when we just move around how this thing moves, but I will come back and cover it. And let me know when you're ready and we're ready. Okay, good thing. Because I'll start. And I'll start, right?
Yes.
All right, guys, here's what we're going to do. We're going to take a nice look at Fusion 360. We're going to take a look at the screen itself, what the whole interface. We're going to create a few objects inside of Fusion 360, and we will then modify those and go from there. Okay, so first thing we want to do here is we can see the Fusion 360 interface is up. We have to the far left what's called the data panel. Now that panel itself will allow you to share your projects with your fellow colleagues here. Now this panel itself will also track as you save your project here and in iterations. So it's somewhat big. So what I'm going to do right here is go ahead on and collapse that so we can see more of the interface. Okay, now what we want to do in Fusion here is we want to do it in steps. First, before you do anything, you have to actually create that piece, and then we will modify that. And then what we'll do is we'll save, but let's figure out how we're going to move around the interface. First thing we want to do, we want to make sure Fusion has lots of features. We want to kind of live in the design area of Fusion. Okay, so to the top left-hand side, we'll click down, we'll see we're in the design section. That way, it allows us to create models as we go through. Fusion also has renders and animation as well as simulations. But for this particular class, we're going to stay in the design section. In the design section, we're going to also take a look at what we call solids, okay, and surfaces. We also have a sketch feature here. Now, let's just take this one step at a time. As we move around the interface, we see that we have a grid here, and I've created somewhat of a box. That's just to be used to show how we're going to navigate around the actual interface. At the very top of this interface here, we have things that we would like to use to create. Okay, and that is going to be our modeling tool set here. Okay, now what I have here is just a regular box on a plane. Everything here that we have lives in what we call 3D space.
Sorry, he knows the software.
Okay. Continue.
Yes.
Now in 3D space, it's an actual environment. When we select something in 3D space, in this case, and I'll come back to the square, I'm just going to use this as an example. We'll select it and it will highlight. It will allow us to move things around. But for right now, we're just going to look at our 3D space. What we're looking at is to the far right, we have what was called a view cube. On the view cube, you have a front view. We can rotate the view cube around to figure out how we will move around in our interface and how things will look. If we get lost here, what we want to do is always click the home button at the top, and that's going to orient our object back to home. Okay, when viewing that, you see that you have a front of the cube, you have a right, top, and a bottom. Okay, in moving around in this particular space, when you select a cube, it's going to ask you in the interface, what portion of the cube do you want to select? So if I'm looking at a cube and creating something, I want to know, it's going to say, what do I want to select in there? Here is the face of the cube that we're selecting. Here is the top, and then it's going to have very small edges. Okay, so we have faces, edges, or we can select the whole cube itself by clicking and dragging across. Anything that we create here in Fusion is going to say that it is considered a solid body. Now I can create multiple solid bodies in Fusion by going to the Create tab here and just clicking down, and I see that I already created a box. Second to this, I want to create a cylinder. Anytime you create anything in Fusion, you have to create these models and put them together to make something out of these actual, what they call primitives. So here I see I have a cylinder. Now, once I click off of the cylinder, Fusion is going to ask me what plane do I want to create the cylinder on. In this case, I'm just going to stick to the basic. I can go to the top plane. It's going to present any plane that I have here to create something on. So once I click on a plane, as you can see, they're actually highlighting to kind of give me an idea which way I want to go. Yes, you can also create something on the actual object that's there as well. So I can click the actual top or the front. I'm just going to go back to home here. Or you can click on the actual base of the plane that you're creating. Now, what it's going to do is it's going to have a crosshair that we have here to allow you to actually draw an object out. Once you draw this object out, it's going to ask you, well, right now you have certain dimensions so far as the circumference of this particular circle here that you have. Now, once you say that, you can key in any number you want it to, because you can see that is highlighted there. It's looking for the dimensions there. Once you click there, you'll look and notice that the cylinder object to the right here that you have a diameter as well as height. These are interchangeable. You can use the small arrow to move the height of the cylinder up and down as you create it. And you'll notice here in the small properties, it's 40 millimeters. You can also change your unit of measurements in the preferences. Once you create anything you want, here, only thing you need to do is just say okay, and then that particular object is created. These are going to be part of the objects that you're going to be putting together to model. Now, very simply, it's the Create tab, and in this case is a solid model. So you will do one more here. For this, I'll create a sphere. Remember, Fusion's asking me what surface do I want to start on? Okay, and it doesn't know until you click and tell it the surface that you want to start on. Or you can create something, as I said before, on the actual surface of the object itself. In this case, I'm just going to keep it to the very base bottom plane here. Once you click, it will allow you to drag and create the object, and then you can put any dimensions that you want in there. So here we have 3 objects in our actual scene. I can say okay in this case. Now, what the problem may be when we first get started is how in the world are we going to maneuver around inside of Fusion? This area overall that I'm mousing around in is called the graphic window. This is our actual workspace. In our workspace, I have what's called 3 solid bodies here. It doesn't have a unique name, so if you want to name your work and be very tidy about how you go and creating these and keeping up with them, you just need to double click on the word and it would allow you to name this pretty much anything that you want in the creation process. Okay, so in this case, I'm just going to say square. And then once you finish naming it, you'll hit enter. And therefore, you will actually be naming that particular object. Now, we know about the view cube itself. We know that we can rotate around in our graphics window using the view cube. And if we get stuck at all, we can go back to home. Okay, what we want to do now is just take a quick look at what else we have to display for that. We'll come back to these 3 objects and we'll move those around. But inside of the graphic window, what we want to look at is how we're going to move around. And this is the actual space inside of the graphic window that we're looking at. What we want here at the very bottom is our display control panel. In this display control panel, when we move the actual whole window around, we have what's very simple called a grabber hand in some things. And what in these particular interface, we can call it panning around. So when we use the hand, we pan around the scene. Very easy to do. Now, the next thing we want to do sometimes in this, we want to orbit, what we call orbit around the scene. And I want us to make sure that we set our orbit, because what happens is the first icon on here in the bottom display control panel is the orbit. Now you will see some drop-down menus for the orbit to allow you to do a free orbit around in space. That means that you can look underneath your object, or you can look on top, or you can rotate around. But I like the idea because sometimes this can get a little bit daunting, because if you do not have very good control over it, you might want to look at the constrained versus the free. If it's free, then that means that things are going everywhere and you really don't have much control. Therefore, you can go back to your home screen here and reorient yourself and then come back to the constrained orbit. Remember, now when we do what we want to do, if we want to pan around the scene, we can click and it looks like a little grabber hand here. There are shortcuts for everything that we do here, and it allows us to move. The next thing we want to do is look at one particular object at a time. If we want to zoom into that one particular object here that we're looking at, if we select a portion on that particular object, in this case, the face on the box, I can go here and say, look at in our display panel, and then it will bring just that particular face to me. And if you don't like that, you can always orbit back in these panels. Now, you have options to see what type of display that you're looking at. Those options are to zoom closer to your display. There is a zoom feature here. You click on that and it will allow you to zoom back and forth closer to your object. You can also zoom the whole window to get it in. And to the next one, you can see how your display that you're modeling look. In this case, it is a shaded display. Or how you want to look at your display, you can click this drop-down menu in the display settings, and your visual style that you're looking at. Right now, it is shaded with visible edges. That means that everything in here is shaded and you can actually see the visible edges that we have here. Now, if we want to see things in lots of times without the shaded views, we can go to what we call wireframe. And therefore, it will show us just what we're looking at in the wireframe view. If that's a little bit easier sometimes to go in and do a little accessing to certain features on whatever that you're modeling. You can go back to the visual style and it looks like a little menu here. And I'll kind of like the shaded with visible edges. And therefore I can see these edges anytime I click on anything. Now, what I've done here, and don't forget that we have this to the far left in our interfaces, what's called a browser. It actually highlights everything that we've created here, and therefore we can see it in a view. We can go back in and we can turn off anything that we're looking at by using the visibility here to the far left. So sometimes the things that you create, you will be able to turn these things on and off. Okay. Now, the next thing that I'm going to do for this quick tutorial is go in here, and I've made a few things here. Okay, what I want to do is I want to do a few modifications to that. Now, I'm using the solid surfaces here. We also have a feature that's in here that will allow me to draw on any surface. So if you're modeling with just solid objects and building your model, this is one way to go. But lots of times you might want to add to your model, and that's what we're going to do. We're going to use one more type of modeling technique. In this case, what I'm going to do next is go in and do a small drawing on top of the cube. And then we'll step to modifying the objects. So here we've created several solid models. We're going to look at the drawing aspect of this in Fusion 360. And so we'll look at the top left-hand side. We'll see that the drawing and what's called sketch is going to show us several different ways of sketching, but we're going to keep it very simple. First thing we want to do is we want to click on the sketch, and what you can also do in here in the Create tab, you can also see the sketch feature. So for the sketch, what I'm going to do is click on the sketch, create. It's going to ask me, what do I want to sketch on? So I can mouse over to any object that I have here. In this case, I clicked on the top, and I'll just rotate that again. I clicked on the very top here of the box that I want to do a sketch on. Once I click on the top of that box, it highlights in blue to let me know that that is the actual plane that I'm wanting to do the sketch on. Then I can see in the sketch menu, I will be versed with all sorts of sketch tools here. In this case, what I'm going to do is just do a center diameter circle on top of the actual box. So I will click on this circle here, and it can allow me to center it or go to an edge, but I'm just going to click an area in here where I can click one time and draw out in a sketch mode the actual circle that's embedded on the box. Once I do that, then in order to finish what I'm doing, and it's looking to do something more to this sketch, I can always hit the escape key. The escape key actually ends what I'm doing, or I can go over to the right in my sketch palette and I can say finish sketch. Once I finish sketch, then that sketch is embedded on top of the actual box. Okay, once you create whatever you want in the solid object, in this case, I've created a solid object, which is the box. I've actually added a small sketch circle on top of that box that's embedded. I want to then do some sort of modifications to this particular box. The modifications that I want to change after I create my standard model, in this case, is I want to do something like extrude. I want to punch a hole directly through this box. Now, remember now, first we had our solid objects, we had our sketches, okay? We created things, and now I want to go over and modify this particular circle that I have in here. What I want to go is to the modify menu. I would click on that modify menu there. I can, in this menu here is interchangeable here that you have. In the create menu, you'll see some of the same things in the modify. I want to do what's called an extrude. Therefore, I want to punch a hole through here. Very simple. It gives you tool tips as to what you're going to be able to do when you're using these particular tools. In this case, I'm going to extrude. So I'll click on here, and it says, first of all, it gives me the actual properties of the extrude to the right-hand side. You can see that it has an arrow in which way that I want to extrude. So for as extruding this particular circle circumference up, or punching a hole all the way through. Now, when I want to punch a hole all the way through this, very simple, what I want to do is I want to look at the direction in the properties of the extrude. It says one side. Well, I have more than one side. I have the front here, that's my actual top, and then I have underneath the bottom. So therefore, what I want to do is make sure that I'm using several operations. Yes, I want to cut and hole through here, but I want it to go in both directions. So I would like to say in here, two sides. So now what's going to happen as I went all the way through, when I finish, it will also allow me to go beyond the distance that I'm having. And you'll notice that I push it all through to negative 7 millimeters. Once I finish this operation to cut through that, I can say, okay, I'm good. So extrude and cut are very interchangeable. Once I say okay, it's going to take the system a little bit longer to calculate that. And what you can see what happens is it cuts a hole straight through the cube. Now to rotate or orbit around here, I can go to the very bottom where it says orbit, and then I can look underneath and you can see that it is actually did this particular operation. So that's one portion of how you can modify an object that you've actually created inside of Fusion 360. There is one more process that we can do. We can look at one more modification to the objects that we have to kind of give us an idea. And then I'll talk a little bit more about what I'm doing in the history of what we have here. Now, the next thing I want to do is I want to modify this just a little bit more. So I want to select, make sure I'm on that square, and I can move around here. And if I want to move back in my view and I can see that I'm at the very bottom, I can just go back to the home here and click on that guy, and it should orientate me back and put everything back in the scene. What I want to do in some cases, you have this cube here. Now it has a nice cutout or a hole in it because I modified it. But the edges that I have here are very, very sharp if I'm modeling. Lots of times you want those edges to be curved in there. I'm going to do what's called a fillet. The fillet modification will absolutely, in this case, make those edges nice and round. Okay, you can see in here, in the modifications here, you have a fillet modifier because I'm modifying the cube a little bit more, and it gives you information as to what inside of the cube it does. In the create menu, you also have the actual part that you can fill up. You can do a fillet, you can do a sweep, or you can do extrude. A lot of these things that you can modify here, but we'll get into those as we go and create those. So I'm just going to go and click on the fillet. On the fillet modification, it wants to ask me, what do I want to fill? In this case, it wants the type of edge that it wants to make sure that I fill. So I'm going to click on one of the edges. It highlights in blue, and I'll just do one of them right now. And it shows me an arrow as to how smooth or round that I want to do that edge. So I'm going to click on the arrow and push it inward, and it's going to round that particular corner. When I'm finished rounding that edge or any edge to it, I can say okay, or I can put in the numbers to specify what round edge that I want to create there. So in this case, I'm going to say okay. And then for the next one, I'm going to use that same operation and say that yes, you can do multiple edges. So you can select one, holding down the shift key, you can select another edge. And then what you can do, you can put the information there, or you can slowly move. Now, if you go too far on, you're going to get an error message inside of Fusion 360. And that lets you know that, hey, you can only go so far, but you'll just have to back off this particular operation again. In this case, my fillet is 5 millimeters on the edge. Okay, and then I can say okay. And the last thing that I want to take a look at as I move around is the actual history. Now, what Fusion 360 does, it gives you a small history to the far left-hand side to show every operation that you have completed and done. So you can bag up, and it's actually recording what you've done. So if you want to bag up some, it's kind of like you can slide here in the history on this little slider, and it will actually undo what you actually created, or it will show you where you are, and you can go back and continue where you might want to pick up from. You can move it forward again, and that works just fine. Okay, so in looking at everything that we have here, if we go through about Fusion, what we have here is we can create things in several different methods. We can use the sketch, create sketch. Here we can create things in surfaces that we have here. We also have a mesh area that we can create more geometric, somewhat soft objects in that instance. In creating things, we have to create those first, and after we create them, we want to make sure that we want to modify them, and then we'll have to be able to have properties in modifying anything that we have in here. We also look to the far left, we have a browser here that's tracking everything that we've created. We can view in recapping, turning these off in our viewport that we have here. We have our area that is the actual area that we will call our graphic workshop. We have the view cube to the right that we can move around. We have also, at the very bottom, our constraints that allows us to orbit around things that we have pan left and right. And only thing we have left to do here, let me bring this back up, is how in the world are we going to be able to move our objects around individually? That's one of the easier things here, to move our objects around individually and to wrap this up. And this is some of the things we probably should have covered a little bit earlier. We want to click on the object itself. In this case, that is going to be a face in the actual box that I created. But now I need the whole actual square box. Here it says body, but I changed the name. I will click on it itself. And now we want to move things around. There is the move here. Once I click on moving it around, it allows me to move this around in my graphic window. And it gives me an option in the direction of how we want to move things around. So in this case, I'm not just moving one part of this, I am moving the whole object around. Now, in order to rotate this object, I can go to the actual object itself, and it has these little small circles that allow me to rotate based on the orientation that I have here. And if you want to use the X angle that's here, and I said a term that we want to be familiar with, the way this is set up as well, not only am I moving this around, these planes have a certain particular direction that we want to be very aware of. In our window that we're looking at, I am moving to the left and right of this. This is called the X distance that we have here, or we call it the X. If I'm moving stuff up and down with this little arrow here, this is called the Y-axis. So up and down is called the Y-axis. Back and forth here are left and right is called the X-axis. Now, if you want to bring things closer to you in your view, that will be called the Z-axis. If you want to see more so of this, I can go back to home, and now this object will move back and forth closer to me. So now we've covered creating objects, different types, solids and surfaces, because that's what we're going to be basically working on. We're in the design area of this. We've actually created things. We've actually modified some of these things by making a cut hole inside of that. We've actually went through and we to the edges that we had here. Okay, let me just say okay here. And we did what we call fillets, which was another modification. We've learned how to move around the interface. We've learned about the view cube. And what we want to do is now any object that we've created here, we want to get that ready for 3D printing. And we want to make sure that we save our projects. So we want to do a couple of little tidying up things. When we're modeling in this area and doing our modeling, we want to make sure that we create multiple components in our modeling here. Now, what we want to make sure we do is once we finish as we go along, we do want to save our project. So as we save, it will give us an idea of what the project name is, and we'll just say sample or demo. Okay, and it will say multiple iterations of what you're doing, and you don't have to go and do an auto save. It will keep using the save tool at the very top, and it will save what you're doing, and you can always go back to what you have. Now, finally, what you want to do is prepare what you have for printing. You want to get ready to export this out for printing. And normally when you print something, it is going to be in an STL format or what's called an OBJ, an object format. In this case, what we want to do is we want to go here and move to File, and this is going to wrap up what we're doing. We want to go in here, we want to say Export. Okay, and then for the type that we want to export, and we know the file name is demo. We know every object in here we're going to export. We'll look down at the little drop-down menu, and then we're going to tell Fusion 360 what we're going to export. In this case, we will probably exporting it as an STL file here for printing, or we will probably export this as an OBJ file. So we'll have to ask the person in the Fab Lab what's suitable for printing. Here's an STL file as well as an OBJ file here. Okay, and then you click the export, and then it's going to prepare the file for export. Okay, it's going to take a few moments to do that, and then it's going to put it wherever you save your file. In this case, I'm going to cancel out, and I think that's going to be a decent overview of Fusion and using and creating primitives to model whatever thing that you have to do. Okay. What we're going to do is we're going to hand it over to the next person that's going to probably be talking about Inventor inside of Autodesk. All right. So Robbie, what we want to say is we have concluded our small demo of the Fusion interface and software. And what I can do is take questions as you model these, but let's take a look at the next feature in here, and that's going to be Inventor by Mr. Ming. Okay.
All right, so I think you're still on the camera.
Yes.
Let's stop share.
Awesome. Thank you, man.
All right, so if you heard Mr. Leathers, this software is called Fusion. It's also on your laptops. The way you can get to it is if you hit the command and space bar and type in Fusion, you should be able to play with this software as well. But for now, we're going to switch over to a whole different software. We're going to now jump to Tinkercad, and Israel's going to teach a little bit about that. So I'm going to ask y'all to just pay attention. Let's look at the software, Tinkercad, and then after lunch, when you have the opportunity of making, you could choose to use Fusion 360, Tinkercad, or SolidWorks. We're going to have one more quick demonstration on SolidWorks as well. So just hang tight, but the software is on your computers when you are ready to make, okay? So we're going to share our screen again. And we'll minimize Fusion 360 for now. Again, if you hold Command button and space bar, this little spotlight search will show up. And in here, if you type in Fusion, that's how you can access Fusion 360 and do some of the things that Mr. Leathers was sharing with you, okay? So, but before you do that, let's now welcome Israel Garza, and I'm taking his chair, so I'm gonna get out of the way. Israel, I'm gonna leave you with Safari and let you take it from there. Thank you,
Would you
sir.
do me a favor and log me into Zoom here, because I'm gonna jump straight from this machine to this machine.
Okay. Okay.
All right. Hi, everyone. My name is Israel Garza, and I'm going to kind of introduce you to the software called Tinkercad. Now, Tinkercad is is introductory 3D modeling software. It's really, really good for people who don't have much experience. Software like, I also want to show you AutoCAD, and what you just saw was Fusion 360. Those menus are pretty complex, right? They're very sophisticated. Same thing for SolidWorks and all of the other like Maya and Inventor and Revit and all these other softwares. They're wonderful, sophisticated tools, but they're a little bit complicated. And so a wonderful intro software is something called Tinkercad. So hopefully I'm sharing my screen. So I'm going to go to tinkercad.com. Again, it's really cool that it's browser based. And so you can, you don't have to worry about having a really strong computer. You can just go straight to it, and all of the processing occurs at the on their side or on the server side. So I'm going to take just a moment to sign in here. Oh, I didn't mean to hit join. I did sign in. I guess I'll be. My mouse is kind of weird. You guys won't have to go through this part about certifying that you're an educator.
Was it free to log
It is
in?
free. Yeah, it's absolutely free. Creating an Autodesk account is a free, is something you can do at no cost. So that's really one of the other cool things is that you don't have to pay for the software. All right, so here I am at the main page, right? And so you can kind of see each one of these little windows here is just some sort of previous project that I've done. But what I'm going to do is I'm going to start off and go straight up to create new design. And you're going to see kind of like a workspace. This is going to be interesting because this is not the normal interface that I'm used to dealing with. Okay. So you're going to see like a general workspace, right? You can kind of see this thing that says work plane. And the way that you kind of make things in Tinkercad is you drag in shapes, and then you're just going to manipulate those shapes. And so you can kind of see over here to the right, you can see this sort of like pre-done menu of basic shapes. And you can see where it's called basic shapes. There's other sub-menus here. So we're going to just start off with basic shapes for now. So I'm just kind of using my mouse here to go in and out. So here we are. I'm just going to drag a shape over here. I'm going to see this orange cylinder. I'm going to click on it and hold and just drag it out of here to the workspace, right? And so now I have this thing that's 20 millimeters in. When I click on it, I'm going to actually bring my work plane, my ruler down here. I'm going to click that, drag it down here, and then it'll start to give me dimensions for everything. So now you can see this is currently 20 millimeters tall by 20 millimeters wide. So if I wanted to stretch this, I just kind of like what you saw Reggie do. You could stretch things. Thank you. You could stretch things here, or if I wanted to make them wider, I could certainly do that. So this is a real simple way to just start off with some shapes. Now, if I wanted to be more exact, I certainly could. I could type in a number here. If I wanted this to be 15, I'm going to highlight the number and type in 15 and press enter. If I wanted this to be on the outer diameter, if I wanted it to be 45, I'd hit enter, and I'd do the same thing for 45 and hit enter. So now you can see we're very quickly able to start creating stuff without having to worry about necessarily work planes or the menus or whatever. We're just dragging stuff in and we're dropping it and we're manipulating some of the dimensions.
Keep it with you. Yeah.
And so when you bring in these dimensions, I'm going to just drag in a sphere here, a little cone. So when you bring in these dimensions, they do have some attributes that you can manipulate. And so if I'm going to click this drop down box here on, I happen to have the cone selected, you can see that I have the top radius, I have a base radius, height, and sides. And so if I drag this, you can see how I can adjust the shape of that just instantly by just dragging these little sliders around. And if I wanted to type in a number specifically, I could do that too. If I wanted this to be 30 instead of 25.94, I could just type in the number and then it sets it to that. And so again, same thing here. So I could adjust my height. If I wanted to take an object and like raise it off the ground, I grab it here and I could raise it and I could click on it and hold it. So you can see I can manipulate and move things around fairly simply with this sort of interface. And one of the other things you can do that's pretty cool with Tinkercad is any object that you have, you can make it a solid shape of that thing or a whole shape of that thing. And so you can see this purple cone that I have. You see where I've got this purple thing that says solid. I can go and click on this thing called whole, and then it becomes a void of that shape. And so what could I use that for? And so you would use that to combine that whole, that designed whole shape and combine it to another object and then union those two objects. And then now you have a whole of that shape. So let's give you an example. So I have this random pyramid thing kind of right over here. And I wish I could fly around. So I'm going to kind of close it this way. So now you kind of sort of see that I have this hole kind of overlapping this cylinder in this space. And so I'm going to hold my shift button and select both objects. And now that both are selected, I can come up here to this menu here and click group. Now, when I click group, it's going to take those two shapes and then combine those two attributes. Now you notice now I have this cylinder with that shape, that whole, that pyramid shaped section carved out of it. This is real useful whenever you've made your design and you need to drop a hole or you need to drop some text or something like that. So let's do something that we want to have text on. So I'm going to come here and go to top here, and I'm going to bring this in here. I'll change my view a little bit, and I'm going to make this just this flat plane here, and I'm going to stretch it out. And I'm going to click on text, and I have this text here. I'm just going to type. I'm going to open this up. I'm going to just type where I work. Well, one of these days I will learn how to type. It's the interface thing that I have difficulty with. Okay. So now I have this thing that says Idea Studio, and I'll hold my shift key. If I were to click on any one of these little handlebars here in the corner, I could stretch it in that direction. You notice, but now I've warped the shape of this thing, right? So I don't want to do that. I want to scale it up, but I don't want it to mess up in its shape. So I'm going to release that, hit Control Z just to get back to my original shape. Then if I hold the shift button and do it, it'll retain the aspect ratio. And so I'm going to shrink this a little bit, and I'm going to, oops, Command Z. I'm going to move this over here. I'm going to make this just a little bit bigger. So I'm just going to position this. Now I'm going to turn that Idea Studio. I'm going to click on whole and make it a whole. And so now I'm going to select, hold my shift key, press the red rectangle, and then press the lettering and go to group. And now I have, it'll take a second. And now I have this cool thing that's got, the name inside of it. And so, yeah, that's very, very simple. You don't have to know a lot of keyboard commands. A lot of these commands are right in front, like right on top. So It's really, really useful. And so that was the thing I opened, right? I opened up a thing and I just started dragging stuff in. But if I wanted to do something a little bit more complicated, I can go outside of basic shapes. I can perhaps, I'm going to go over here to hardware, and you can see I can bring in other objects in here. So if I wanted to make, say, a robot with like connectors, these connectors here can fit into, like, here's the like a shoulder piece, like the female shoulder piece, and I can bring this here, and I know that this is going to fit into here at that scale. Oh man, I really want to move it the way I want it. So just FYI, using the Apples versus the PCs, you know, the mouse controls are a little different. So I'm not exactly doing what I want, but you get the concept, right? So you don't have to worry about should I extrude, or where's the command, or what's the command key. In just a second, I'm going to jump over to AutoCAD and I'm going to show you, you know, if you really wanted to be precise, what you could do drawing under that software. So there's, yeah, again, a lot of things you can drag and drop. So I just drug that in. I'm going to go back to my main page. And now you see this little preview of what I just drew, right? So I'm going to go click back on it and click on Tinker This. And also this has the ability to share, just like what Reggie was saying a moment ago, you have the ability to share. So this is going to load. I didn't have any groups, but this whole will load in that in just a second. It's just taking a moment to load. The point is that it will save every one of your actions. You don't have to worry about losing any data. If you're working along and there's a power outage for some reason, or you're accidentally disconnected from the internet, this will save everything. You don't have to worry about it. It's not going to your local drive. Every action you do is saved on the cloud. So, and again, you can share this. Now, some interesting thing about this, I don't know why it does that. It will take, when you click open file, it randomly selects a couple of words and creates the file name of that. So for whatever reason, it created my file name called Ingenious Biggery. I wouldn't know what to call that. So I'm just going to click on it and do test object and rename it. Then click away. And then that's my new thing. So I'm going to come back over here to my main menu, and you can kind of see now it's called test object. And so you'll see a lot of the things that I've made, I don't really change the name too much. So you can see, I mean, it's very useful. I've been drawing for a while. I've been drawing in AutoCAD for a while, but there's so many occasions where I just need to make something quick and was it quick and dirty, I guess. And Tinkercad is just a much easier way to do that. So I really recommend you taking a look into this software. What I'm going to try to do next is I'm going to try to finagle wanting to share my screen from this one to this other one. So just give me a second, guys. All right, so I am sharing another laptop that's got AutoCAD loaded on it. And again, this is going to be the software that it's quite sophisticated, just like SolidWorks is, and just like Fusion 360 is. It can do a lot of things, but it's just a different sort of interface. And so here we are looking at the work plane. I'm not going to have the mouse, but here we are. We're looking at the work plane, and I just happen to draw some random triangle. And so I'm going to try to do this on the trackpad. I've never really drawn that way. So just like in Fusion 360, you're basically drawing on certain planes. And so whenever you have your object, like if you have your design that you sketched in from, just on a napkin or something like that, you can save that file, take a photograph of that sketch, and then save it to your computer, and then you can import that image into AutoCAD. And then what you're basically going to have to do, I mean, there's other ways to do this, but what you're basically going to have to do is trace that object. And so so whatever, you'll have this photograph of a pencil sketch, but you're going to have to recreate that object with specific line work here. So let's draw something here, just some random thing here. And so that's doing something like that. So let's say that that was kind of what I wanted to draw. Usually, so what I just did was I just drew line work with something called polylines. You can draw with lines or polylines or splines or a lot of different things. And so I don't want to get into there's no way for me to get into the specifics and the details of the difference between those objects. But let's say that this, just for fun, this little shape here is my drawing that I wanted to draw, that I brought in. And so I'm going to type in the code spline, SPL for spline. And so now if I touch each one of these points, you're noticing it's creating this sort of curved shape here. Create my closed object and then center. And so now I have this thing here. So this is like a nice smooth thing. It's usually when you're drawing things from a sketch on like on a piece of paper, they're going to be curved lines. And so splines are what you're going to want to do. And it is the line type that you want to make. If you're going to draw straight edges, I would say polylines. I do have a couple of videos. We do have a couple of videos at the Idea Studio that we've made online, and I'm going to try to navigate to those super quickly.
Yeah, that's fine. I thought it's SolidWorks. SolidWorks is different than this. It's not all the SolidWorks.
So if you guys want to learn how to do like specifically how to do 3D modeling, we've made a couple of videos here that you can kind of see. We have like AutoCAD lesson 1. And so this will walk, I'm going to click on this video and it will walk you through all the details. You can kind of see, I'm going to go full screen on this. You can kind of see down here at the bottom, what's the subject matter that's being done. You can see that I'm currently at circle. You can see offset and trim and fillet and extend and scale, revolve. All these different things are currently in that lesson. So I would recommend if you want to just search for Idea Studio and WHI in YouTube, you'll see the Idea Studio WHI channel. And then there's a couple of videos loaded in there, and just kind of start with lesson 1 and then lesson 2 and lesson 3. And that'll basically show you all the details that you need in order to go from scratch. It starts at the very, very beginning of this is where the save button is. This is how you draw a line. These are what the menus are. And so I think it's a good thing for you to use in addition to what you're getting today on how to 3D model your objects. If you want to just, again, start with Tinkercad, I think that's a wonderful place to start to go from nothing and then create your 3D model object. I don't know how long I've gone, but I think that's the extent of the information I feel that's relevant to talk to you guys about. So thank you very much for your time, and we're going to move on to the next person. Take care, guys.
That's the main one, right?
Yes.
Okay. Thank you. That was
You're
awesome. I think you stole the show. So I think Israel stole the show by introducing Tinkercad because it was so convenient and easy, and it doesn't require any extra software. You could use it on your web browser. So whether you have PC or Mac, it just works. So we're now lining up Min to talk about SolidWorks. Thank you. We are gonna get a PC device for this because it doesn't work on Macs. So this is strictly lecture. It's not gonna be something that you could play with. It's being installed. So let's say about 5 to 6 minutes more to go. But while that's happening, let's take an opportunity to just kind of do a quick recap, right? So I'm going to share the screen on this PC, and as a quick recap. So going backwards, you saw. Let me see, make sure. Okay, so you started off with Mr. Leathers telling you about Autodesk. Sorry, give me a second here. It's not okay. Autodesk Fusion 360. Notice that this software is available to all HCC students. All you have to do is use your W number to log in. You can download this on your personal devices and on a Mac or PC. Use your school account, which is the HCC W number and your password that you use to sign up for classes at the college, and then download the software. Play with the software. I always say that the quickest and the best way to learn something is by actually doing it. I don't learn from just reading a whole bunch of books. And believe me, Mr. Leathers brought the whole book, and I could probably show it to you on the webcam here. He brought a whole book, right? Now I could sit here and read the whole book, but I don't think I'll learn as much, or at least I don't think I'll retain as much if I didn't actually get my hands on the software and actually did practice myself. And the times when you have challenges or problems, so say I wanted to play with the cylinder, the time when I'm trying to solve that problem, I'll retain that knowledge if I have some sort of problem, if I have to really think about, okay, why is this not working? The more effort I put behind solving a problem, the more I'll remember it, I'll recall it, and I'll learn from that experience. So I highly encourage you to practice using these softwares. Again, they're available to you for free. It doesn't cost anything. So all you have to do is download it, use your student account to log in and use it, but practice and play with it and tinker with it, right? So speaking of tinkering, let's look at the second software that Israel shared with you, which was Autodesk Tinkercad. There are already tons of 3D designs made available that you could download and start to tweak. So, in our Designathon, our competition asked for an award. So here's some files. Here's a base that's already made. Maybe instead of the man that's standing on the base, maybe you convert that into a golf player for the purposes of our demonstration. And you submit that as a file, right? So again, our goal is for you to learn the software, the digital skills, and then compete for a given challenge. So Tinkercad, again, so easy. Go to the website, set up a free account. As Israel shared, have a portfolio of all the stuff you create, and then you could bring that to our Fab Lab, and I'll just zoom into one of them. I forgot he's got a fancier way of managing. I need that mouse. All right, I'm losing it. It's somewhere here. It's gone. All right. So nonetheless, here it is. So make it face me a little bit. Okay. So you could submit these things as long as you are learning in the experience and you're meeting the challenge needs. You'll be fine, right? So I highly encourage you all to play with the software. Tinkercad is obviously the easiest one. Doesn't matter. You could even load it up on your smartphone, with the browser capabilities. So go ahead and do that. Now, he also shared with you a third one, which he took the laptop, so I can't show you, but that's a third software that you can engage in that does the same thing. We're going to try to show you one more, SolidWorks, as soon as we get that going. That one is strictly for PC. So are we ready with SolidWorks? Not yet. Okay. So how about this? Let's take a 5-minute break. Allow y'all to kind of stretch your legs, and we'll come back to this. So I'm going to stop share here. So let's take a 5-minute break while we wait for our awesome friend Mohammed to install SolidWorks on that PC. Min is already ready for you guys when you are as soon as we get the software ready. But Min, any comments about SolidWorks the students should be aware of before you?
Actually, I want to make a quick comment on both AutoCAD and also SolidWorks and Inventor. The software itself run about $4,000. And as a student, You sign up using your student ID, you get it for free, a complete package, professional package. So already, it's already more than pay for your tuition right there, as it is, each one of those. As far as the AutoCAD go, you can download any AutoCAD product. That is Revit for architecturing, Inventor for mechanical, Civil 3D for civil, and it's all free as a student. So just want to let you know the tool are provided for the student to be successful, and it's free. And on top of that, if you do this competition, you get more money on top of that. So it's an opportunity to make money, as it is.
Right.
So
So
it's-
that's what I did not realize it was a $4,000 software
Oh
package.
yeah, and it's depend on what you add into. It's just like a car. The more accessory you add to it, the more expensive it gets. So it average about $3,000 to $4,000
Wow.
commercial rate.
Okay, so that right there is what I call a barrier to entry. Other people that are in the industry, unless they have that much money lined up,
Right.
they don't have access to the software. Sorry, I'm gonna try to get on the camera. So they don't have access to that software. You as students, you have access to the software. You could download it through solidworks.com. You could register with your W accounts. You can also take classes at HCC
Correct.
to learn SolidWorks
Correct.
and and become an expert at the software. And they use this software for pretty much, as he mentioned, civil engineering, from if you want to design bridges to all the way to building designs, home designs, pretty much anything you could imagine that needs to be, created in tangible, way. They use this software. So highly encourage y'all to consider learning these softwares, because right when you go into the industry, there's a lot of, you could become a 1099 contractor. If you're a SolidWorks expert, you're a Fusion 360 expert, or you're a Tinkercad expert, people will hire you to make their models. So let's say I wanted to print this remote, right? I can't just print it. I have to create a 3D digital file for this. I have to define each component. I have to define the colors and what it is before I can send it to a fabrication lab to actually print it or make it. So the skills here are fantastic. Do you teach SolidWorks
Yes.
under?
Yes, I teach SolidWorks, and just for student knowledge, if you learn taking a CAD classes here at ACC, for example, and you're trying to get into NOV, you must know SolidWorks, because that's what they use. If you're trying to get into Cameron, then you must know Inventor, because that's what they use.
Mhm.
So knowing which company using what software and learn that get you a head start versus all the other trying to get into a company. Schlumberger down the road is using Creo, for example, and that's why they have different software, because each company using different thing.
Okay.
And
So, Min, is there videos or something you can show as an example of what SolidWorks looks like, or do we need to install it on a PC for you to show it? Sure. So, Min, we'll get that computer going.
okay.
But otherwise,
So real quickly,
Israel is back. That's the camera that you're going to talk into.
so real quickly, I just wanted to mention
Go ahead.
about today's project. You're going to be making your items, whatever it is you create today. Your digital item. You're going to physically make those things, as I understand it. So you can come here to the Advanced Manufacturing Center or Smart Manufacturing Center, or you can come to our space, the Idea Studio, over at the Northwest Campus at the WHI building. So I'll tell you that whenever you're designing anything digitally, the thing that you have to keep on the forefront of your mind is how it's going to be made. And so, when I showed you Tinkercad, or when anyone shows you the software, the output of that digital file can be done in a lot of different ways. And so you'll want to make sure that you're designing such that it'll be easy to make for whatever output you're thinking about. I think you guys might be making trophies or some sort of model. Whatever you make, it might be easy to create with one tool, but difficult in another tool. So you'll want to think about, what is the tool that I want to use in order to make this physical object? And that's going to drive your design process. And so, for example, if you're going to be doing something in 3D printing, then you want to be mindful of the way the shape is. If something has something called overhangs, right? So if something is leaning, if it's standing straight up, that's printing going from the top to bottom, right? But if it's leaning like over quite a bit, then when something's printing, then this part of the area that's underneath the model is called an overhang. Then you're going to have to print something called supports to hold that thing up during the printing process. And so if that, the problem with the supports is that sometimes it'll leave some physical artifacts, and like the texture of the surface is going to be rough or not very smooth. And so if you need that to be smooth for your part, your final version, then 3D printing, and maybe in that orientation or that even that process may not be the ideal for that part. So you want to keep that in mind. If you wanted to create something that you're going to cut shapes out of something, that's really ideal for laser cutting. And so it's basically taking a 2D shape and then cutting it out of a 3D material, and then you have this object. So it's very important to make sure that you know how you're going to make this object, and just of course scaling your object. So when I draw something in 3-dimensional space, I'm drawing it. There's no reference point of like how big or small this thing is. And so I would always recommend that you draw 1-to-1 scale inside of your digital universe. And so now sometimes when you're drawing something full size 1-to-1 scale, you might be drawing an entire city block, right? You might be drawing something that's feet and feet or even miles wide. But if you need to print it on a piece of paper, you can deal with the scaling of that sort of stuff later. But it's always best to draw something in real size, right? The actual full size scale. And that will also help you determine if you can make a thing at scale, right? So if let's say that you're laser cutting something and then you draw little lines where you want little slivers of something to come out, but that little sliver is very important. That if you draw it and it looks fine on the computer screen, but you realize when you realize you go to cut it out, it's too small to make. It's actually something too small to make. Then you're out of luck, right? So there's nothing that you can do because you've already designed it. So just make sure that when you're designing to scale, you'll know that, oh, this little sliver is 1/100th of a millimeter thick. That's too thin, so I'll have to redesign my object or scale the object up. So the idea is just to make sure that you always keep in mind the manufacturing and the fabrication at the forefront of your mind when you're designing, because that's really going to make it go your process go a lot farther and be much easier. The idea of designing, I mean, one of the things you have to really understand on the front end going on is that the idea that there's going to be iteration or failure. So you start off with your first try. We just call that version 1, right? And then when you print it out, it didn't work, and then you try to go back to the drawing board, then that's version 2. Sometimes you'll have to go through dozens of versions before it actually comes out right. And so the idea is to know that that's something that's going to be a part of the process. Failure is expected. So don't be disheartened. Don't worry about something that doesn't work. Or if you create like something to be a hinge and then that hinge is too tight or that hinge is too loose or these things or the space is too far away, then you'll just go back to your computer and then readjust and then reprint. Just keep in mind that you guys have, at least the current times that we're currently in, have a huge advantage over manufacturing processes in the past. It used to be that you would have a company or some business who was creating a part to be manufactured, that once they create their design, usually it was at paper, it wasn't digital. Once they create their design, they'd have to pay a third-party company, send that file or send those files to another company, pay that company to create a manufacturing process to make that first version 1. And that's an extremely expensive process to tool the machine, to be prepared to make it in some sort of material. So it takes a lot of time and it takes a lot of money. And that's only from version 0 to version 1. And so Now that process is completely condensed. And so you can do that. So going from 1 to 2 to 3 to 4 is a much faster process. So just always keep that in mind when you guys are designing stuff. Okay. All right. That's all I wanted to say.
All right, so let's take that 5-minute break as we talked about. Just hang tight. We'll come back. Leave the live stream open. I'll cut the sound for us. We'll play some music out here in the main lobby, and the students in they're down the hall, right? All of you. Some of you are waving. Looks like. So take a break. Come back. Let's say 11:30. We'll show. We're gonna have a small change of plan. Instead of SolidWorks, we're gonna show you Inventor, which is the other tool from Autodesk. That one is quicker to load. Autodesk is we have it in the Fab Lab. So if you wanted to go play with it, you could go check it out in the Fab Lab, but we're not able to showcase it on our PCs and the projectors and all that we have out here. So we'll show you Inventor in 5 minutes, take a break, come back 11:30, go take a bio break. There are bathrooms on both sides of the wings of this building. So we'll come back in a little bit. We'll have the music playing and we'll He's got everything working, so you can screen share, take over. All right, so we have changed positions, and we're going to be in a different room to try to showcase this this tool. This is the Inventor tool. So here we go. We're now watching live. Min, you are good to go, sir.
Okay, thank you. Well, thank everybody for showing up. I apologize for the delay there. Just to let you know, why are we using Inventor, SolidWorks, and other software? Well, the problem with that is when you use AutoCAD and you draw up and design what you want, but if your customer decided to change their mind, you have to change 2 or 3 views, and that just takes time, and the customer won't wait. So that's the reason why we use this software. It's called Inventor, and basically what it is a parametric software. What that means is that it's a dimension-driven part rather than as AutoCAD is a part-driven dimension, meaning that you can change the dimension, it will change the part. So what I'm going to do is I'm going to go ahead and start working. And what it does is allow for you to access the different module. In this case, it's part, drawing, assembly, and presentation. And then also there's animation, and we'll go through that as well. But to start out with, I'm going to go ahead and start with part. Okay, that's how you create new part. Take a moment there to load up. And the difference between this and versus AutoCAD is that when you start it out, it's going to ask you what work plane do you want to work with. You got top, front, and right side work plane, 3 work planes. I know I'm saying this and you're looking at me like, okay, where do you see that? Well, it's under the origin folder, and in that you got YZ plane, XZ plane, and XY plane, which is the 3 work plane that we have. In this case, we have XY plane appear right here. So I'm going to go ahead and start my sketch right here. So I'm going to start a sketch, 2D sketch, and I'm going to start on XY plane, and there's my work plane. So with this, if I want to draw something, okay, so here's what I'm going to use an example of to make things to help you understand how things work. So let's just say that I went to Home Depot and buy 4 pieces of lumber, and I'm gonna make a flower bed. Okay, so I went to Home Depot, I bought this 1 piece of lumber, and I'm gonna go ahead and create another piece of lumber, and I'm gonna create 2 more, and 1 more. All right. Now I got 4 pieces of lumber. I went to Home Depot. I threw it down on my driveway, and now I'm going to connect them together by using a nail to connect them together. That is, in this particular software, it's called Constraint. Constraint a relationship between any 2 items. In this particular case, I want to join these endpoints together. To do that, I'm going to do constraint called coincident constraint. I'm going to grab these endpoints here, and they're joined together. Once they join together, you cannot separate them. You can stretch them, you can move them around, you can even change the angle and all that stuff, but you cannot separate them. All right, so let's do a couple more real quick here. And I'm going to join this together, and I'm going to join all this together, and I'm going to join this last 2 together. All right, I did say that I want a flower bed, but that doesn't look like a flower bed. I don't know what it looked like. So what happened is that we got to apply some more constraint to this. So I'm going to apply a horizontal constraint. Horizontal constraint. There it is. It's now laying flat left to right. I'm going to apply a vertical constraint. So these are, again, we call it a relationship. And I explain to you why we need this relationship in a moment. All right. And I'm going to apply some more constraint. I'm going to make these 2 lines parallel to one another. Okay, they're parallel. I will make these 2 top lines to perpendicular to one another. Now they're nice and square. So no matter what you do, you can drag, you can move, you can do whatever. They're always going to be nice and square. Okay. Now I'm going to go ahead and apply equal constraint between these 2 lines. And the reason why I apply the equal constraint, because once I'm done with that, I'm going to go ahead and throw a dimension in there. Let's just say, okay, let's just make this 1 inch. All right. Now, a moment ago, I did show that. Okay, so I want to show the equal constraint, meaning I put my cursor on equal constraint, meaning it highlights the 2 lines, and meaning they're equal to one another. That is a relationship between any 2 items. Meaning that if I change this dimension, I double click on that, type in a new value, they both change together. The customer say, I want to change to 4 inches, no problem, they're 4 inches. They can sit there and change their mind all day long, and I get paid by changing number. I don't have to redraw nothing. That's the whole idea behind this, okay? Also, because of, let me zoom in. Okay, there you go. All right, so now that I got a fuller constraint, I'm gonna go ahead and lock this design. Now I lock this design, it turned it black, meaning it's fully constrained. On the bottom of your screen to the right-hand side, that also fully constrained, meaning that they're not missing any dimension. So your instructor cannot take point away from you because they're fully constrained. All right, so I say finish sketch. I can actually finish sketch, and now I can actually work on, I finished with a 2D, now I can actually work on 3D model. But before I do that, I'm gonna go back to the sketch real quick. I wanna get the name, I'm gonna edit the sketch. I'm gonna right click and choose to where is that? Dimension property. Okay, this dimension is called D0. Every dimension you put in is going to have a name. And this particular case is D0, meaning it's the first dimension. Okay, and it's going to be D1, D2 if you add more to that. So I know that this dimension is D0. It have a name D0. I'm finish sketch. I'm going to extrude this, meaning I'm going to make it into a 3D object. But I don't want it just to make any 3D object. I want to make it D0. And I'll tell you why in a moment. So I name it D0, and I say, okay. So that means that if I ever change my sketches from 4 inches, edit sketch, from 4 inches to 6 inches, for example, And if I update it in the sketch, everything increases by 6 inches, meaning that the whole design I changed it by 1 number. Okay, next thing. With this, I can actually do a hole. So I'm gonna do a hole right here, and I'll change this to let's call that D0. D0. Remember, D0 was 6 inches, right? Obviously, if 6 inches is the same size as a rectangle, so it doesn't work. So I'm going to divide this by 2. Okay, so half of that, and then I want that also D0 divided by 2. Oops, by 2. Okay, and I'll locate its center. So D0 divided by 2. Everything put in as an equation. So this hole will always be the half of the size of the object, and the distance will always be half of the size of the object. So no matter what you do, that hole will always be on the center. And if you can rotate this, you can see the hole right through there. And the reason why you do that is because in case a customer change their mind again, so you can add a feature. And instead of doing a regular hole, you can do a threaded hole. What is a threaded hole? I have no idea. Well, threaded hole is a hole with thread. And you don't know what they are, that's okay. Don't worry about it. Because whatever they provided in here, it exists in real life. If it doesn't exist and it doesn't provide in here, it does not exist in the real life. And so for that reason, you must choose whatever that standard size drill bit, standard size tap hole, and things like that. So you can choose from there. I'm not going to choose anything. I'm going to leave it at, well, actually, let's just do that. Just so for the grid that you can see what's going on. Let's just go 1 inch maybe. I'm going to change to 1 inch hole. Too small. Let's try 2 inches. Yeah, that's fine. And this happened to be 2 and 2 thread. Number 2, 4.5 unified coarse thread for every inches. And I say, okay. And if you rotate just a tiny bit, you can actually see the thread in there. Barely, but you can see, there you go. You can see the thread in there. All right. Now, here's the problem. You as a designer, and by the way, when I do hire people, not here at the outside industry, when I hire people who use Inventor, SolidWorks, for entry level, I pay 18 to 22 an hour, and depend on experience, and more if you know a lot more. For the money I pay you, you better know how to design, because I'll tell you this other feature I'm going to show you real quick is called, and there are many features on here, but this one I'm going to show you. This one I call shell command. So imagine this box right here. I want to make sure that I have a opening on the inside. Okay. And I did the shell, and it tells you the shell right here, but you don't see nothing. Say, hey, wait a minute, something not happening. I don't see anything. Okay. And that's the reason why. The reason why is because I purposely made a mistake by, and that's what's nice about this software. If you made a mistake, all you have to do is go back to that feature and edit feature. It allows for you to correct that. So in this case, I forgot to do a remove face. I want to remove face right here, and say, okay. Uh-oh, I didn't pick that. Sorry. Still making a mistake. This one was accident. It wasn't purpose. So this one I say edit feature. Remove face. I want click on it. I want this face to be removed. Okay. Now I got this face removed, as you can see. Cool. Now, now that you got this done, and you send this over to the manufacturing guy. This happened to be Professor Phil here in the manufacturing shop. And you say, hey, Mr. Phil, can you machine this for me? He's going to be looking at you and laughing at you. And he's going to tell you that you show me how and I'll do it. And I'll tell you why. What tool, what mill do you get in order to get behind this? I'm going to change the color of this. Sorry. Let me change the color so I can express this a little bit better. Let's change this to orange. Oh, it goes fine. Okay. So what tool do you get to get behind that wall back there? To the machine that void back there. You know, you have not seen a 90-degree drill bit, have you? Well, of course, then if that's the case, then the manufacturing people cannot do it either. That's where the problem is. We can sit here and model this all day long, but you got to make sure you know manufacturing. Otherwise, they cannot make this part. But that's okay. I can fix that for you. You can actually grab the shelf function here and move it before the whole function. This is called a reordering process. So you reorder the shelf before the hole. What happened is that you shell and then you drill the hole. That way you don't have to redo your whole design. You can just change the process and you get it done. That's what's nice about that. Okay, so then I'm gonna go ahead and remove the shell command. I'm gonna delete that for now. And I want to show you some other things, for example, like the fillet. Now, the reason I want to show you the fillet is because this is really cool. So here you can actually do a fillet. This is what you want to remove sharp edges to avoid injury and things like that. So that's what fillet's there for. Also, it makes it aesthetic so that your design looks better. So I can put a fillet in there, and let's make it 1 inch. There you go. It's 1 inch fillet, right? You can do more than 1 edges, and it come out nice and pretty and so on. I'm going to delete that because I'm going to do that again. And that was called a constant. I'm sorry, not constant fillet, but you can get fancy. So you don't have to keep doing shell. I want fillet. Okay, so you don't have to do that constant, because you can actually do a variable, meaning that you can say, okay, I want that, but from start is 1 inch, and from end I want it 0.25 inches, and in between I can add another piece right here, and I say 1 inch, 0.25. So 0.1 here, I want it 0.5, for example. And you can apply that all over. And of course, you can actually start on another edge as well. So I'll say, okay, add another edge to that. I'm gonna do something similar to that at 0.75, for example. Okay, so you can get fancy and elaborate with all these, if you will. There you go. So you can do all that stuff right there. Okay. Also, all right. How about let me add another feature right here. I'm going to put a new sketch. I'm going to put a circle on here. For the sake of time, I'm not going to dimension. Just to move things faster. All right. So I'm going to add a cylinder right there. And with this, I want to add a thread. I have no idea what size of thread I'm going to put on. You don't have to. You grab on the size of the shaft, it figured out what size of it, and it makes suggestion for you. And you can change a different thread, but it will put it on there for you automatically. So, a lot of design issue that you may or may not know, it can make recommendation. Now, I say make recommendation, and the reason I say that, because as the designer, you know what you want. You don't let the software dictate you. You need to dictate the software. Although it give you a lot of feature to save you time and all this other stuff. So be aware of that. Let's see what else. Okay, I'm gonna get rid of this thread. All right, the reason I want to get rid of this thread is that I now finished with this object the way I want it, whatever the feature I wanted. But now I want to make this into more customized, as you will. I want my company name on here, for example. Well, okay. So what I'm going to do is I'm going to create a work plane. Okay, so I'm going to create a new sketch. And I'm going to put a text in here, right in the round area right there. And I say, okay, this is a test, or your name, company name, whatever. You can change the size of that text. Let's make that 0.24. Okay. This is a test. Okay. And I'm going to finish the sketch. And what I want to do is I want to, what I want to do, I want to emboss that, and I'm going to grab on the text, and I want to wrap that to the face, and depth is let's make the depth is
make a 0.25, for example. Okay. Uh-oh. Where is it? Oh, it's on the other side. I grabbed the wrong side. There it is. So it make an emboss of that object that you want. Your name, your company name, and so on. Emboss is actually a raised face, but you can actually modify that and edit feature, and make an engrave, meaning it's cut into the material. As you can see, it's cut into the material. So you can get this personalized any way you want. For example, maybe you want to label this as the left side, it's the right side. Maybe you design a brick or something like that. You can do that. All right, so that's the simple feature, and for the sake of time, I'm just gonna go briefly on some of the main feature. But while we're doing this, we can also bring in several other items. For example, I can actually go to new, because I want to take you through the whole process, not just this simple building of an object. And the reason why is because we now, let's just say I'm going to create a drawing. Take a moment to load up the drawing. Okay, I can insert the drawing. Let's save the part. Oh, okay. Yeah, it want me to save the object before I can actually use it for drawing. So let me go back. Oops, where is it? Oh, here it is, part 3. Okay, so let's just save this. Save as. Let's save it on the desktop, and let's call this one demo 1. Okay, let's call that demo 1. All right, so I got a name, say demo 1, and now I'll go to drawing, and I can bring in base. Demo 1 is good. And if you see this, if you like this to be a front view, fine. If you don't like, you can change it by click on this object. And then rotate it, whatever the case is. You can rotate it any way you want. So let's assume that you want this. Okay, fine, that's good. And locate top, front, right side, ISO. And you got the whole thing, top, front, right side, and ISO. And you can right click and you can say retrieve model dimension. Okay, so what it does, it will grab all your dimension that you put in earlier and it put it in there for you. So you don't even have to worry about it. It put it all in there. It remember what it is and everything else. This radius. Oh, there it is. Okay, so it put all that dimension in there for you. And if you want to get fancy, let me see. Come on. There you go. If you want to get fancy, you can actually right click and property. Oops. Oh, let's do this one. This is the base view. Property. Come on. Okay, here it is. See, where is that? Edit view. I was trying to change the color. Edit view. There you go. That's the one I was looking for. I want to shade it. Okay, cool. Didn't do that one. Edit view. And I want to shade it. Of course, I had color and everything else. It will change that too. So now you got this whole thing and you got this drawing. Now, I want to point out one thing. This dimension is 6 inches. At this moment in time, I can still be able to edit the dimension from 6 inches to say 5 inches, for example. Not only that it changed here on the drawing, it will also change it on this part, on the original part as well. So they both related. You don't even have to remember where you put them. It will automatically update itself. Okay, so that's where that's why it's important that you do this, because it has a relationship that if you change one on one model, it changes on the other. Now, let me take you into the more advanced design feature. Say, for example, I'm going to go to new. And there's 4 modules: the standard part, standard drawing, And in this case, we also have an assembly in the presentation file. So I'm going to bring in multiple parts. For example, if you design a car engine, for example, you can create an assembly. Oops, that was not what my intention. So close that. New. Standard IAM. This one for welding, this one for standard. So I'm going to create standard. And what I will do is I'm going to create, I don't want to create, I want to bring in place item.
Hey, Min.
And on my desktop, I should have
Hey, Min.
desktop. Yeah, desktop. There you go. I got this demo that I made earlier. So I'm going to place this model in here. And then, of course, I can bring in more part if I want to. But even more important, this is what's cool. You're going to like this one because I don't want you to do a lot of work. So in this case, I'm going to go to place them from the content center. All right. So in this content center, you got this big old library that depend on what you design. 5 minutes. Yeah. So so you can bring in all these parts, and for example, you can bring in bolt, and you don't even know all the bolt, but they are there. So you can bring all the bolt and things like that. Okay, so let's see. You can bring sheet metal, tubing, pipe, conduit, other part, drill bit, bushing, whatever the case is. So you got all these things that you can bring in. You don't even have to do anything. There's structure member, there's a valve and different thing in here. Shaft part, there's all kind of thing in here that you can bring it in. So let's just say we're going to do a hex head or something like that. Okay. I don't know what it is. I just drag and drop. Uh-oh, it didn't work. Try that again. Oh, you're gonna say okay. There it is. And then you say, okay, I want to place it right there. And you can actually grab on the hole, and it figured out what size of the bowl it should fit in there automatically, by the way. And then when you're done, you say, okay, apply, and the bowl, and you can choose a different size and so on. I'm going to leave it alone as it is. And it's automatically in there. Now, here it is. Here's an assembly. So the assembly is done. I'm going to go ahead and, for time's sake, I'm losing time here. So I'm going to go ahead and save this because I got a couple more modules to show. And say desktop, say it's demo 2. Okay, so that's my assembly. From here, I can actually open up a new module. It's called standard IPN. Okay, and desktop. It is assembly. Okay, so in this, I can actually do a tweak component, meaning I'm going to move this object up and down all around. And the reason I'm doing this is because, there you go. Now that I got it all done, I can actually create a new storyboard. Okay, clean. Okay, and then I can actually where am I? Quick component. Okay, drag this out. That looks good. Check mark. And let's just do one more just for the sake of doing it. Quick component, grab on the object, grab on the arrow where you want to move to. So, okay, that looks good. All right. So now that you got this thing is done, you can actually click on a video and a current storyboard. Yeah. Okay. It's going to publish. Give it a second. Okay. So complete. And let's play it. Oh, I think it publishes in my desktop. All right. Detail. Demo. Okay. Where did it go? Where did it go? There should be an animation. I'm looking for animation. I don't see it. Okay, so I lost that somewhere. Oh, here it is. Like, there you go. There's the animation. And with this animation, you can save it as WMV, AVI, you can send to your customer, whatever the case is. All right, so that took care of the 4 module. What else do I need to show? I need to show something. I think that's it. That's the 4 modules on there. But more than anything, I want to show the library, how big the library that is, and you know, you can have access to all that. Yeah, those are the 4 modules. I have complete that. So, like I say, my name is Ming Pham. I'm with the drafting department. Number is 713-718-8410. Have any questions? Contact me. I'll be more than happy to help. Not just Inventor, but SolidWorks, Autocad, and things like that as well. So anything drafting software, I can assist in that. All right. Well, thank you, everybody. And I think my time's up, I believe. Thank you. And I'm going to go ahead and close this one out. So.
All right, thank you so much. So I'm gonna go ahead and mute our presenter here. Thank you so much, Min, for sharing Inventor. I think he showed us the last one. All right, folks, so look, food is here, so I'm gonna make this quick. I'm gonna share my screen with y'all. I just wanna tell you the quick recap. So, you know, you've had multiple softwares being shared with you. So you know that you have access to all of these things. So the quick recap there: Fusion 360 by Mr. Leathers, Tinkercad by Israel, and then SolidWorks/Inventor. So I don't think we saw SolidWorks because we had some issues with the PC, but you definitely got a chance to see Inventor. And what an awesome way, like if you could build up that skill. You heard Min say, you know, he's hiring for people like around $18, $20 an hour just to do this work. So if some of you get really good at this, then you could turn this into a consulting gig and do this for a living. So I'm gonna also, let's move on to the next slide here. The recap of this entire you know, seminar, all 3 presenters, is gonna be on YouTube. So luckily you guys are watching us on YouTube because of the way our setup is in this building today. So it's gonna stay here. If you ever wanna go back to it, just bit.ly/design8cc to go see it. The projects are due by 8 p.m. Thursday. Here's the link: hcc-design-a-thon, THON 2, number 2.devpost.com. So give this link at least 24 hours for it to be live. But this website is where you are going to submit a screenshot of what you create on Tinkercad or 360 or Fusion 360, or you know, if you're brave enough to go for it, the Inventor that Min showed. Make your designs 3D on it, and then take a screenshot of that design. Make sure you have the STL file. So when you save this work, it's going to be a .stl file. Make sure you save that file, but for the purposes of the judging, you're going to submit us a picture, okay? A PNG or a JPEG, so typically a screenshot. So you're going to upload that before 8 p.m. Central Time, Thursday. So plenty of time for you to make multiple designs. Remember, each person can submit up to 5 designs. So you don't have to submit just one. You can submit as a group, you can submit as an individual, you can submit up to 5 designs. So make sure that you leverage this. Again, it's going to be due on the 28th, Thursday, 8 p.m. If you want to come back and utilize any of this that we've shared with the Fab Labs or the West Houston Institute, I'm going to put up that slide again. So they're open Monday to Thursday, 10 a.m. to 3 p.m. That's HCC West Houston Institute, or the lab that's right in front of you. Some of you are sitting in the hallway. The lab is right in front of you. That lab is Tuesday and Thursdays from 10 a.m. to 7 p.m. So you can come, later in the evening and still use the software, the computers that have all this installed, and finish your design. So we're giving you plenty of time to finish your 2D, 3D designs and submit it. Okay. So without further ado, I'm going to ask that we take a break. Boy, it's been a fantastic morning. So it's lunchtime. So I know there's a 10-second lag, so I'm going to hear a bunch of you with the sign of relief, but this is your opportunity to make friends, enjoy food. I'm going to have some music playing out here. So just relax. After lunch, it's going to be your opportunity to make your designs and help others. By the way, I totally think if you know how to use these softwares, help other students with their designs for the golf tournament that we're making for, and make sure that you spread your wisdom with others. I always say being kind and being helpful will take you far in life. So just continue to practice that. And again, enjoy the food, enjoy the music. I think we've got 4 types of pizza there. So let's take a break, enjoy. We'll see you back at 1 p.m. For those on the live stream, just feel free to hang around there or turn it off, and we'll come back at 1 p.m. Thank you. Let's get the music going. All right, so we're gonna record some of the projects that are coming in. So let's check. Y'all don't have any projects to show, do you? All right, who's got something to show? If we could get from this table first. Are y'all just starting? Okay, that's fine. That's starting. Let's go to the next one. They're just starting. This is where the key, show me. You're using Tinkercad? Oh, you may have to mute your, otherwise we're gonna get this crazy feedback. That's a nice projects that are coming in. So mute your live streams because I'm walking around with my mic live. Want to say hi? What's your name? Isabel? And then y'all too. Y'all showed me.
My name is Yasmin.
Yasmin?
Your name?
Xavier.
David?
Xavier.
Xavier. Nice. Can you mute the front? It's making that sound. All right, do you have something to show? You're working on something?
So what I was
hole in
thinking
one.
was
Nice.
blade, and a guy is just standing right here with the golf club, just going act like he's gonna put the ball inside the golf. And, make
Awesome.
Only one.
Awesome. Keep it up, man. That's good. I really like the creativity of that one. Hole in one there. All right. You got something to show me? Gonna sneak in here. Yes. Wow. I like it. Trying to get that star. It's not cooperating. Maybe you just leave it on the side. Look at y'all. It's nice. You're zooming in. Have you used Tinkercad before? First time? You just picked it up in like this couple of hours? So let me catch your names. Name.
Oh,
Jennifer.
Lila.
Huh?
Lila.
Leela. Man, I can't believe you never used it before. Your proficiency is amazing. All right, what about you? What you got? You got basic, oh, you got a base there you're building. And you put that together quickly because you knew it was coming, right? I'm kidding. That's nice. You guys got something for me? Yeah? Whoa. Is that Well, how are you gonna make the stars float when you make it? It's amazing. Did you use Tinkercad or any of the softwares you learned today before? First time? You guys are fast. Okay, well, finish and submit before Thursday. Thursday, 8 p.m. Min, you should see what they've done in the few minutes that they had today. You should see the student projects. I'm blown away by the creativity out here. You're impressed too? What's your name, man? You're a
Nicole.
teacher, right?
I'm a tutor, yeah.
Okay, cool. You're impressed, Fernando?
Yes.
Thanks for bringing that to my attention.
Yeah, no problem.
That's awesome. So that's our digitize. All right, I'm gonna go back off the live stream. We'll continue to play the music.
I'm great, brother.
Thank you, thank you. And we've got students still working, so going video mute, audio mute, and we'll come back, wrap up